In this video, we're going to talk about the last topic of AMA 1110, which is the interval estimations when for the population mean mu when the population standard deviation is not known. Now, in this case, we use what they call the student t distribution to get the confidence interval for the population mean. So, just to introduce the subject, most of the time, recall that our first formula for the confidence interval, right, this one, it's, we can find a confidence interval when the population standard deviation is given. Okay? This confidence interval formula we use sigma here, right? The population standard deviation and the normal distribution, z alpha over 2. But most of the time, in real studies, right, in fact, the population standard deviation is not given. It's not known at the very outset of a statistical study. So what do you do in this case when the population standard deviation is not given? Right? How do you, well, what we do is we estimate the population variance or standard deviation. We estimate it by the sample variance in this case. And we actually find out that the following random variable, x bar minus mu divided by s, okay, sample standard deviation, follows a t distribution with n minus 1 degrees of freedom. Okay, so let me describe that more precisely. So let x1, x2, xn be random sample from a normal distribution, has to be a normal distribution. We mean mu and variance sigma squared. Then the following random variable, sample mean minus mu divided by s over square root of n, follows a student t distribution with n minus 1 degrees of freedom, and the 100 times 1 minus alpha percent confidence interval on the population mean is given by x bar plus or minus t alpha over 2 n minus 1 s over square root of n, where again x bar is the sample standard deviation, s is the sample standard deviation. So remember, this is the square root. So remember, the sample variance is summation xi minus x bar squared divided by n minus 1. Right? It's an n minus 1. N minus 1. And of course, the sample standard deviation is just the square root of the sample variance. N is the sample size. And t alpha over 2 n minus 1 is the value of the t independent variable for the t distribution with n minus 1 degrees of freedom, such that the probability that this normalized random variable is in between minus t alpha over 2 and t alpha over 2 is 1 minus alpha. This minus t alpha over 2 plays the same role as the z alpha over 2 in the normal distribution. So what's this t distribution we're always talking about? Well, this t distribution is actually just like the z distribution, but with an extra parameter called nu. Nu is the Greek letter nu. It's like the V, and it's called the degrees of freedom, and it's equal to the sample size minus 1. This is the degrees of freedom. And so picture, it's basically like a normal distribution with an extra parameter called the degrees of freedom. And in fact, it kind of has the same shape as a normal distribution. And so each t nu is bell curve centered around 0. And each t nu is more spread out and flatter than the normal curve. So this is the normal curve. This is the red standard normal curve. And as nu approaches infinity, degrees of freedom increases it gets more flatter, as you can see, and as new degrees of freedom or the sample size gets larger, right, T nu actually converges to the normal standard normal Z curve, this red one. So let's try to calculate some T alpha nu values. And okay, so for example, find T alpha nu is T 0.0513. So in this case, the alpha is 0.05 and your degrees of freedom is 13. So let's look at our standard T table, okay? Student T distribution table. You can see it's just like the Z table, right? It's a right tail table, and it the area to the right of T alpha nu is alpha, just like the Z table. But the difference is alpha on the top row represents the area to the right of T alpha nu, and nu is the degrees of freedom is on the left hand column. Okay, so for example, for nu equal to 13, right, degrees of freedom equal to 13, we look for the 13th row here, it's right here, so you go across, and alpha must be equal to 0.05. Okay, so 0.05, you look, and it goes, so you go down. And the intersection, again, like the Z distribution table, is where T alpha nu is equal to. So in this case, it's 1.771. 1.771. What about here? T alpha nu is T 0.001. So alpha is 0.001 here. And degrees of freedom is 20. So what's T? So again, we look for T nu. So degrees of freedom is 20. Let's look for 20. 20 is here. And then the nu is alpha is 0.001. Alpha is 0.001. So here. Then you look for the intersection is 3.552. So that is how you use the student T distribution table. Okay. Now let's look at some questions. So following a sample of measurements of concentration of sulfur dioxide in the Bavarian forest. So sulfur dioxide is basically what causes acid rain. So they take basically 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 24 measurements of the concentrations of sulfur dioxide in various parts of the Bavarian forest. Find the 95% confidence interval of the mean sulfur dioxide concentration in a Bavarian forest. Okay, so here note that the population not standard deviation not given. So that means you use the T distribution formula for the confidence interval. So it's x bar plus or minus T alpha over 2 nu equal to n minus 1, right? Nu or n minus 1 times sample standard deviation by square root. Okay, so what's all these figures? So x bar is the sample standard deviation. What's it equal to? Well, you just sum up all these figures, sulfur dioxide concentrations, and divide by 24. So here, note that n is equal to 24, right? 4 times 6. So we already have n here. We have n. Now let's look for, so then we have, I'm not going to do everything. 22.7 plus all the way down to the last figure, 6.4 divided by 24. In this case, it's just going to be 53.92 milligrams per meter cube. So this is, now what's our sample standard deviation? Well, first let's calculate the sample variance. Remember the formula is x I minus x bar squared divided by n minus 1. So in fact, this is like, so it's like 52.7 minus, I won't do everything again, minus 53.92 squared. And then you add all the way down to the last one, 56.4 minus the mean, which is 53.92 squared. And then you divide by n minus 1. In this case, it's 24 minus 1. Then in fact, what you get is 101.48. So the sample standard deviation is the square root of the sample variance, which is the square root of 1.48, which will be just 10.07. Okay, so this is our S here. Now, what's left to calculate is the T alpha root 2. Okay, so what's T alpha root 2? Well, we have a 95% confidence interval, which implies that alpha must be 0.05, which alpha root 2 must be 0.025. And the number of degrees of freedom, n minus 1, is 24 minus 1, which is 23. Okay, so we're looking for T alpha root 2 n minus 1 is T 0.025 and 23. What's that equal to? Well, 23, let's look. 23 is here, and then 0.025. 0.025 is here. So intersection is 2.069, okay? The 2.069. 2.069. There. Okay, so we have everything. So we just plug it into here. Okay, so we get 53.92 plus or minus 2.069 times S, sample standard deviation, divided by the square of n, which is 24. Okay. So in the end, what do we get? So therefore, the 95% confidence interval is 49.67 and 58.17 milligram per meter cube of sulfur dioxide concentration in the Bavarian forest. So let's do one more example. Peter is a professional dart player. He wants to find out whether he has a tendency to throw the dart upward or backward. He's aiming at the center. I mean, this should be downward, upward or downward. He has recorded 10 darts vertical shift in centimeters. These are the vertical shifts in centimeters. Find 95% confidence interval in the mean vertical shift. Does Peter have any tendency to throw upward or backward or downward? Downward. Okay, so again, sigma is not given here. The population standard deviation. So you use the t distribution, confidence interval formula. So t alpha over 2 is 1. Sample standard deviation divided by n. Okay, so then you again, so here n is 5 times 2 is 10 here. Okay, x bar, you just add up all the vertical shifts and then you divide by 10. So in fact we get is like 0.055. Then again the sample standard deviation is summation x I minus x bar whole square n minus 1, and then it's all square rooted. Okay. Now let's just figure out the sample variance first. So it's gonna be, so okay, I'll just write down first term as 0.5 minus the mean 0.055 squared all the way up to the last term. And then 10 minus 1, and that will be 0.094. And sample where its sample standard deviation would this be then square 0.094, which is 0.3066. Okay. Now again, what's our T alpha n minus 1 then? Alpha over 2. So again, it's a 95% confidence interval, so it's like T.025 n minus 1 is 13 minus 1. Degrees of freedom then is 9, right? Mu is n minus 1, which is 10 minus 1, which is 9. So 0.025, 0.025. So again, it's this one, 0.025. But then we go to 9. 9 is the degrees of freedom. So 9 go here. The intersection is 2.262. 2.262. So you just plug it in. So then it's 0.055 plus or minus 2.262 times sample standard deviation 0.366 divided by square root of 10. This will be the answer. So then therefore the 95% confidence interval in the population mean mu is minus 0.174, 0.284 centimeters. So since 0 is contained, the middle contained in the 95% confidence zone, there's no tendency of Peter to throw upward or downward. No tendency. Okay. And maybe you can try the last example here. So the answer here is the confidence interval in this case is 76.95 to 82.40 to 2 significant digits after this. Okay, just try this out.